Welcome to this comprehensive training session on managing access to Azure resources. Today, our main focus will be on mastering Azure role-based access control, specifically focusing on built-in Azure roles. Let us get started. Let us begin by answering the fundamental question, what is Azure RBAC? Azure Role-Based Access Control is the primary authorization system you use to securely manage access to your Azure resources. Instead of granting broad, sweeping permissions to everyone, RBAC allows you to define access rights at a highly granular level, which is based strictly on the day-to-day activities a person needs to perform. Why is this important? It ensures that your organization complies with stringent security requirements while allowing engineers and administrators to do their jobs without unnecessary roadblocks. You achieve this by assigning a specific role to a specific identity at a designated scope. A critical concept to understand early on is that Azure RBAC uses an additive model. This means that if a user is granted permissions at a high level and a lower level, the most privileged access right takes precedence, combining their capabilities. Looking at this flowchart, you can easily perceive the core mechanics of Azure RBAC. On the left, we have the security principle, which represents the user or application requesting access to an Azure resource. On the right, we have the role definition, which dictates exactly what actions are allowed or denied. At the bottom, we have the scope, establishing the precise boundary where this access applies. The magic happens in the middle. A role assignment seamlessly binds the principle, the role, and the scope together to securely grant access to the resource. Now that we understand the framework, let us talk about the who. In Azure terminology, the entity requesting access to a resource is called a security principal. A security principal can be a standard human user, a group of users, a service principal for an application, or a managed identity used by an Azure service to authenticate automatically. Why do we have so many types? Because modern cloud environments require access for both human administrators and automated software systems, and each needs a secure, trackable identity. When you create a role assignment, the very first step is identifying this principal. Here is a deep dive tip for your daily operations. Always strive to assign Azure roles to groups rather than individual user accounts. By managing access through group membership in Microsoft Entra ID, you significantly reduce administrative overhead and make auditing your security posture much easier. This mind map breaks down the different types of security principles available in Microsoft Entra ID. Starting from the center, we branch out to users, which can be internal employees or external B2B guests. Next, we have groups, which bundle users together for easier management. On the application side, we see service principals, which act as identities for your registered applications. Finally, we have managed identities, which can be either system assigned to a specific resource or user assigned as a standalone entity, eliminating the need for developers to manage credentials. Moving on to the what, we encounter role definitions. A role is simply a structured collection of permissions that explicitly states what actions can or cannot be performed against a resource. Azure provides over 70 built-in roles right out of the box, which are designed to cover the vast majority of common administrative and operational use cases. Why should you use built-in roles? Because they are maintained by Microsoft, automatically updated as new features are released, and they perfectly align with industry best practices. If we look under the hood, a role definition is essentially a JSON file. It contains an actions array, which lists allowed operations, and a not actions array, which lists explicitly denied operations. As a deep dive concept, you must remember that not actions always take precedence over allowed action items. If a permission is listed in not actions, the user cannot perform it, even if a broader action rule seems to allow it. This class diagram illustrates the anatomy of a role definition. At the top, you see the core properties every role shares: a role name, a description, a list of allowed actions, a list of denied not actions, and the assignable scopes where the role can be applied. Below this, the diagram splits into two categories. On the left, built-in roles, which are pre-configured and maintained by Microsoft. On the right, custom roles, which administrators can author from scratch when the built-in options do not perfectly match their organization's unique requirements. Let us take a deep dive into the 4 foundational built-in roles in Azure. While there are dozens of specialized roles, these 4 apply broadly to all resource types and form the backbone of Azure RBAC. First, we have the owner role. An owner has full administrative access to all resources and holds the critical ability to delegate access to others. Second is the contributor role. A contributor can create, update, and manage all types of Azure resources, but crucially, they cannot grant access to others. This is a vital distinction for security. Third, we have the reader role, which grants view-only access to resources without the ability to make any changes. Finally, the User Access Administrator role exists specifically to manage user access to Azure resources without granting access to manage the resources themselves. By properly utilizing these 4 built-in roles, you can quickly establish a highly secure separation of duties within your cloud environment. This flowchart visually compares the capabilities of the 4 core built-in roles. Starting from the left, we trace the paths for owner, contributor, reader, and user access administrator. Notice how the owner path leads to yes for both managing resources and assigning access. The contributor path leads to yes for managing resources, but explicitly routes to no for assigning access. The reader is restricted entirely to reading data, while the user access administrator bypasses resource management to exclusively handle access assignments. We have covered the who and the what. Now we must determine the where, which in Azure is referred to as the scope. The scope defines the exact set of resources that a role assignment applies to. In Azure, you can specify scope at 4 distinct levels. At the top, we have management groups, which can contain multiple subscriptions. Below that are subscriptions, which act as billing and management boundaries. Inside subscriptions are resource groups, which logically containerize resources. And finally, at the lowest level, we have the individual resources themselves, like a virtual machine or a database. Why is scope so important? Because scopes are structured in a parent-child relationship. When you grant access at a higher level, such as a subscription, those permissions physically flow downward and are inherited by every resource group and resource inside that subscription. By carefully selecting the narrowest possible scope, you actively limit your organization's risk. This hierarchical diagram demonstrates how Azure scopes are nested. At the very top, highlighted in pink, is the management group. Below it in blue are the subscriptions. Nesting further down in green are the resource groups. And at the base, highlighted in yellow, are the individual Azure resources. The arrows illustrate the downward flow of inheritance. If you assign a role at the management group, the permissions travel down the arrows to every single element below it. Let us bring it all together with role assignments. A role assignment is the actual mechanism that grants access by binding your security principal, your chosen role, and your specific scope together. You can manage these assignments seamlessly through the Azure portal, PowerShell, the Azure CLI, or programmatically via REST APIs. The standard interface for managing this in the portal is the Access Control IAM Blade, which is consistently available across all scope levels. Here is a critical deep dive point about inheritance. Azure RBAC operates strictly on an additive model. This means you cannot use a role assignment to revoke or deny access at a child scope if that access was already granted at a parent scope. For example, if you grant a user the contributor role at the subscription level, you cannot assign them the reader role on a specific resource group to restrict them. They will still retain their contributor rights due to inheritance. This flow diagram illustrates a real-world role assignment scenario and how inheritance cascades. On the left, we identify the IT audit group. We assign them the built-in reader role. We apply this assignment at the subscription scope, highlighted in green. The dotted lines demonstrate the resulting inheritance. Because the assignment lives at the subscription, the IT audit group automatically receives reader access to every resource group and virtual machine contained within that subscription. As we conclude our conceptual learning, we must emphasize the most important security concept in cloud administration, the principle of least privilege. This principle dictates that you should only grant users and applications the absolute minimum level of access they need to perform their specific job functions, and nothing more. In practice, this means you should actively avoid assigning broad roles, like the owner role, at broad scopes like the subscription level, unless there is a strict business justification. Why is this critical? Because if a user's account or a service principal's credentials are ever compromised, the attacker's blast radius is strictly limited to that identity's permissions. By carefully selecting tightly scoped, built-in roles, you protect your organization. When auditing an identity, always use the Check Access tab in the IAM Blade to uncover their effective permissions, including anything they have inherited from higher up. This decision tree provides a simple framework for applying the principle of least privilege. When a user needs access, first ask, do they need to manage other people's access? If yes, use the User Access Administrator role. If no, ask, do they need to create or modify resources? If yes, assign the contributor role, or better yet, a resource-specific role. If they only need to view configurations, assign the reader role. Regardless of the path chosen, the final step is always to assign that role at the lowest possible scope to minimize risk. For our final slide, let us cover the how-to of assigning and managing roles practically. When you need to grant access, navigate to your target scope in the Azure portal, whether that is a resource group or an individual virtual machine. From the left-hand menu, select the access control, IAM, blade. This centralized interface provides a unified, intuitive wizard. To create an assignment, simply click Add, then Add Role Assignment. You will be presented with a tabbed interface where you first select the built-in role, then move to the Members tab to select the specific user, group, or managed identity. Finally, you click Review and Assign. For those of you deploying infrastructure at scale, manual portal clicks are not efficient. In those deep dive scenarios, you should automate your RBAC deployments using the Azure CLI command AZ role assignment create or the Azure PowerShell complete new AZ role assignment. Thank you for attending this training on Azure built-in roles. This linear flowchart shows the exact step-by-step workflow for the Azure portal. First, open the target resource. Second, highlighted in pink, click the Access Control IAM blade, which is the gateway to all RBAC settings. Third, initiate the process by clicking Add Role Assignment. Fourth, browse and select the appropriate built-in role from the catalog. Fifth, select the member identity from your directory. And lastly, click Review and Assign to finalize the permission grant.